Hi there, welcome to the second part of this video. What we're going to do for this video is we're going to really look at what happens to the ions based on what group they are in. I don't expect you to remember the charge of every single ion that we come across. There are some little tricks and techniques that you can use to work out what they're going to be, providing that you've got a periodic table with you. So you will need your periodic table for this part. So make sure you've got that out and somewhere where you can see it. All right, let's just go through the groups one by one, well, at least the ones that are going to come up on the syllabus. So we're going to look at group 1, group 2, and group 3. We're going to skip a few groups because you don't get asked questions about them. And then we'll look at group 6 and group 7, and we'll kind of see what happens with the differences there. We'll also have a look at some ions that are a little bit different because they're in that sort of middle bit, the transition block that you guys probably know about. All right, so group 1, first of all. Group 1 elements all make +1 ions. They're all 1+ charge because every single one of them is going to lose 1 electron. If we look at lithium, that's element number 3. Look at sodium, element number 11. 4, 5, 6, 7, 8. And we look at potassium, which is element number 19. And one more here. You'll notice that every single one of these atoms has 1 electron in its outside shell. There's one there, and one there. Now, it's the easiest thing for this to do to get a full outer shell is to lose their electrons. Every single element in group 1 is like this, so all group 1 metals lose 1 electron and form positive ions, just 1+ ions. Now, let's compare that to group 2. So, group 2, these guys all make +2 ions. Because if we draw the elements in group 2, let's just do beryllium because it's nice and easy. We've got 2 in the first shell, 2 in the second shell, and magnesium. I won't draw calcium because I can't be bothered. But for magnesium, we've got 2 in the first shell, 8 in the second shell, and 2 in the last shell. So you can see here that we've got 2 electrons in the outside shell of beryllium, 2 electrons in the outside shell of magnesium. So all group 2 elements, all group 2 metals, lose 2 electrons and form 2+ ions. If those elements are in group 3, then I'm sure you can predict what's going to happen here. I'll just draw aluminium because there's no point in really doing anything else. Again, we've got 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3. So here's my aluminium atom. You can see that there's 3 electrons on the outside shell. So you've guessed it, yes, the group 3 metals lose 3 electrons and form 3+ ions. Now, there are some other metals, some positive ions that you do need to know about. Some of them that you won't be able to just predict from where they are on the periodic table. These ones you do just need to learn. They're not easy to learn. There's not really a pattern to them. You just have to keep on reminding yourself of these. So silver makes Ag plus ions. Copper makes Cu2 plus ions. Zinc, that makes Zn2 plus ions. Lead, that makes Pb2 plus ions, but it can also make Pb4 plus ions. You'll notice that this is in group 4. It's the only group 4 element you'll be asked questions about in the GCSE, but please be aware that it might be lead 2, in which case you write it in word form as lead 2 in Roman numerals with brackets, which is the Pb2 plus ion, or it might be written as lead 4 in Roman numerals, which is the Pb4 plus ion there. And the only other metal you might be asked about in the exam is the iron ion. So iron ions can be Fe2 plus, or they can be Fe3 plus. And again, we just write that as iron 2, which is the Fe2 plus ion, or we write it as the iron 3, which we can write as Fe3 plus there. For these ones, you don't need to be drawing a dot and cross diagram. You will never be asked to draw a dot and cross diagram of silver, copper, zinc, lead, or iron, because these are very, very complicated ions, and the only reason you're asked them in questions is that they're very, very common, so you really should know about them. All right, let's move on to negative ions then, our anions. For anions, let's start off looking at group 7 because it's a little bit easier to understand. So group 7 elements, things like chlorine, bromine, iodine, they all have 7 electrons in the outside shell. So let me just draw fluorine here. Let's just get a title, group 7. Group 7. If I draw out fluorine, there we go, draw this here, you can see that there's a gap that needs to be filled with an extra electron. And the same with the next one along in chlorine. So if I do the same for chlorine, 2 electrons in the first shell, we're going to have 7 electrons in the second shell, and we're going to have 8 electrons in the second shell, 7 electrons in the final outside shell there. 1, 2, 3, 4, 5, 6, 7. And obviously we've got a big gap. We've got a gap there that needs to be filled. So because these have a gap of only 1 electron, that means that they need to gain electrons, and so these will form negative ions. So all group 7 elements will gain 1 electron and form -1 ions. Okay? Now for group 6, let's just do oxygen for this one because, again, I just can't be bothered to draw out more than one of these. Here we go. We're going to just draw this. You'll notice that if it's in group 6, it's going to have 6 electrons on the outside shell. And look, we'll notice that we've got 2 electrons missing there. So that means that all group 6 elements will gain 2 electrons and form 2 minus ions. You don't need to worry about group 5, but it does follow the same kind of procedure. If you have just a group 5 element, the most common thing for it to do is to form a 3 minus ion. Okay, there are no other elements that you will be asked about, but there are some compound ions which we will look at in the next video.